Welcome back to The Explainer. So, have you ever wondered how a smartphone sitting in Tokyo seamlessly understands a picture message sent from a laptop in London? Today, we are demystifying that exact invisible magic. For all you network learners, CCNA students, and developers out there, we're diving deep into the unsung hero of the OSI model, Layer 6. That's right, the presentation layer.
Here is our quick roadmap. We're going to start with the OSI big picture, meet our network translator, explore its three main jobs: formatting, encryption, and compression, and finally, wrap up with some real-world applications.
All right, Section 1, the OSI model context. Let's set the stage. You probably already know the OSI, or Open Systems Interconnection Model, is this 7-layer framework created to standardize how computers actually communicate. Honestly, it's like a massive digital assembly line. Data starts at the very top application layer where you interact with your software, and it moves all the way down to the physical layer where it literally turns into electrical pulses. But today, we're zooming in right near the top of the stack.
Which brings us to Section 2, meet the presentation layer.
Before we get into the technical nuts and bolts, let's consider a pretty fundamental problem. How do completely different systems actually understand each other? I mean, think about it. If a Windows PC is talking to a Linux server or an iPhone to an Android, they absolutely don't speak the same native language. Their internal architectures are entirely different. So who exactly bridges that gap? Well, the answer is Layer 6. The presentation layer is, essentially, the universal translator of the network. Imagine two people who don't speak a word of the same language trying to negotiate a business contract. What do? They hire a translator. Layer 6 does exactly that. It ensures data coming from the application layer of one system can be flawlessly read and understood by the other.
So the real question is how it translates. The presentation layer actually handles three massive pillars of work to pull off this seamless communication. First up, it handles data formatting and translation. Second, encryption. And third, compression. We're going to break these down one by one, starting with how the data is actually structured.
Okay, Section 3, formatting and translation. Let's look at how raw data gets organized.
Every single second, networks handle an incredible variety of data types, right? When you send a message, Layer 6 steps in and formats it. It handles character encoding, like UTF-8 or ASCII, so your text actually displays correctly and doesn't look like alien gibberish. It structures data using JSON or XML for web services, and it even manages your image formats, like JPEG and PNG. Basically, it translates raw application data into a standardized network format before it leaves, and then unpacks the whole shebang when it arrives.
Moving on to Section 4, the power of encryption.
Now, this second pillar is arguably the absolute most critical one for modern networks. In today's digital landscape, security isn't just a nice-to-have. It's absolutely crucial. I mean, you definitely wouldn't want to send your online banking password across the internet in plain text. That's where the presentation layer comes in. It locks your data down. It takes your readable data, which we call plain text, and scrambles it into completely unreadable ciphertext before it ever travels across the open, vulnerable network.
And this is exactly where protocols like SSL and TLS operate, right here at Layer 6. When you log into your bank or, buy something online, you rely on secure HTTPS connections. That S stands for secure, which literally means the presentation layer is hard at work taking your plain text and scrambling it into ciphertext. Interceptors, they just see mathematical gibberish. No way they're getting your data.
That brings us to Section 5, data compression mechanics. Have you ever tried packing for a long trip and you had to use one of those vacuum seal bags just to fit all your clothes into a suitcase? Well, the presentation layer acts kind of like a vacuum seal for your digital packages. By compressing the data, basically shrinking the file size down by removing redundant bits, it ensures that data transfer is as fast and efficient as possible. This saves incredibly valuable network bandwidth. And when that data reaches its destination, the receiving presentation layer simply decompresses it back to its original state so the application can actually read it.
All right, Section 6, real-world Layer 6. Let's see this in action.
Let's zoom back out and look at the exact top-down encapsulation flow when you open a secure website in your browser. Step 1, you type a URL, and the application layer creates that initial HTTP request. Step 2, that request drops down to RStar, the presentation layer. This is where it formats the data and encrypts it, magically turning HTTP into HTTPS. Step 3, it drops down to the session layer, which opens the connection to the server. This whole process, encapsulation, just keeps adding information at each layer until your request is blasted out as electrical signals. Let's use an everyday example we all know. When you send a WhatsApp message, it doesn't just, teleport directly to your friend's phone. Your WhatsApp application creates the message data. Then, the presentation layer functions kick right in to format that text using character encoding, and crucially, it applies that famous end-to-end encryption. It's translating your private message into a secure, network-ready format before sending it on its way.
Now, there is an important difference between theory and practice here, especially for you network students. The 7-layer OSI model is amazing for isolating specific network functions. But in practice, the internet actually runs on the TCP/IP model. In TCP/IP, the presentation layer, and actually the session layer too, gets completely absorbed into a broader application layer. But don't be fooled. The crucial tasks of formatting, encryption, and compression still happen. They're just bundled together under one larger umbrella now. So, if there is one ultimate takeaway you should remember from this explainer, it's this. The presentation layer is the translator of the network. It ensures secure and understandable communication. It's this invisible worker, but man, without it, our computers would be speaking totally incompatible languages, our high-res images wouldn't load at all, and our private data would be visible to literally the entire world.
Before we wrap up, I want to leave you with a bit of a provocative thought. We know Layer 6 acts as our secure translator, diligently encrypting our data before it hits the open web. But what new vulnerabilities emerge if this translator itself is compromised? I mean, what happens to global network security when the encryption protocols we rely on are completely broken or bypassed? It's a fascinating question, and one that really sits right at the cutting edge of modern cybersecurity. Thanks so much for joining me for this explainer. Keep analyzing, keep learning, and I'll see you next time.